Hello, welcome to another video. In this video what we're going to do is I'm going to derive for you the 1D kinematics equations, the one-dimensional kinematics equations that we're going to be using when we do kinematics. So, which is our first topic, the study of motion, okay, how things move with time. So equations 1 and 2. Alright, so to derive these equations, by the way, most of this is done with just algebra. That's one way to do it. So velocity, we're going to start with this definition. So start with velocity, okay? And we're going to use this definition to derive one of the equations. So velocity equals the change in position, so final minus initial, over the change in time. Right? So I'm just expanding out what delta means. So x final minus x initial, so the final position minus initial position, over the final time over the initial time. What we're going to do is I'm going to cancel out t0. Why? Because so t initial is the initial time. And if we just set this at 0, so starts at 0 seconds, we can just eliminate it. So v then equals x final minus x initial over t final. So what we're going to do now is we're just going to multiply this guy over, and this will give us, we're going to multiply it over, so x final x final minus x initial equals v t final. What we're going to just do is just call this time now, because if you think about it, time final minus 0 is the change in time, so I'm just going to call that time. So x final minus x initial is v times t, and then all I'm going to do is add this guy over, so x final equals x initial plus vt. And this right here is equation 1. Okay, this is the first equation that we're going to use. If you want the final position, it depends on your initial position in space relative to a coordinate system, plus your velocity times the time that's elapsed. Okay. The next equation that we're going to use is just kind of average velocity sometimes. We won't really use this much, but the average of anything is really defined by 2 of the terms over 2, so this will be the initial velocity plus the final velocity over 2, and this is how you'll get the average. And this is just kind of a definition of what average is, right? And this guy will be equation 2. But we won't really use this much, so won't use often. Okay. So now that's equation 1 and 2. Equation 3, okay, is we're going to start with definition of acceleration, just like we did with velocity. Okay, so I'm going to write it out. I'm going to do the same thing. V final minus V initial over T final minus T initial. That guy gets 0. This guy I'm going to call just T. And so we get A equals V final minus V initial over T. And then if you multiply this over, and then we just need to add that over. So V final equals V initial plus AT. And this is equation 3. So the next equation actually kind of requires some ingenuity. And so what we're going to do is we're going to start off. So this is going to be the equation 4 derivation. We're going to start with equation 3 and add V naught to both sides. So we're going to start with V final equals V initial plus AT. We're going to add V naught to both sides. And then what we're going to do is we're going to divide by 2. So this whole thing over 2. And this will give us v initial plus v final over 2 over here. This is just going to be v initial plus at over 2. Okay? This right here you may recognize as just the average velocity. This right here is v naught plus 1/2 at. Now what we're going to do is we're going to call, so we're going to solve, so keep this in mind. We're going to solve equation 2 for v bar. And so equation 2, if you remember, looked like this, where this can also be written with the average above it, and we're going to solve it for v. Okay? So x final minus x initial equals v bar t. We're going to divide by t. So we're basically getting back our velocity, and now we're going to plug that in. So what we're going to do, plug in now. Right here. So v bar equals v initial plus 1/2 at. We're going to take this and we're going to just slot it in right there. So x final minus x initial over t. And then what we're going to do is we're going to solve this, solve for x final. So we're going to take this t and multiply it over. So x final minus x initial equals v initial times t plus 1/2 at times t again, which will be 1/2 at squared, and now we're just going to add this guy over as well. So we're going to get x final equals x initial plus v naught t plus 1/2 at squared. And this is equation 4. It should be noticed, since like equation 4 is much more complicated than the first 3, I don't expect you to have to derive any of this. Okay, I'm just showing you where the equations come from so that you can see they didn't just fall out of the sky, right? They are derived from the definitions of position, velocity, and acceleration, right? They come from somewhere, right? There is also a way to derive them using calculus, but we won't do that one. So, equation 5, where are we starting? Okay, so we're going to start with equation 3 again. Okay, and solve for time. A lot of these are just, we want to put them in terms, so usually like knowing x final is pretty important. That's why, because final position, right? That's what we want to track. That's why we solve this guy for final position. But sometimes we want to solve it for maybe final velocity, because that's an important thing to know sometimes too. And so a lot of these quote-unquote derivations are just, you're just moving stuff around to solve for things that are often solved for. And so it's really just taking the legwork out of this stuff for you to have to do during problem solving. You'll already have the equations. Move over the initial, so subtract it. I also do recommend coming up with an equation sheet and having it for exams, okay? Because they are timed, and so it's important that you have something to reference during exams and you don't have to look it up each time for when they're closed book exams. Okay. So V bar equals V final plus V initial over 2. Plus, as you use these equations more, you'll get used to it. You'll start to memorize the equations as you use them more and more. Okay, so what we're going to do to finish derivation of this guy, we're going to plug this guy in here, and we solve this guy for time, right? So we're going to take this, we're going to slot it in here. So again, it's just rearranging things, really. V final plus V initial over 2. And this was V final minus V initial over A. So you get X final equals X initial plus, you guys remember this? You do this 2 first, then you do these 2, right? So V final squared minus V final V initial, and these guys commute, so it's not a big deal. What commute means is you can multiply them in any order. You can shift this back and forth. So V final V initial equals, oops, this one's plus, sorry. Oh wait, no, this one's minus, the second one's plus, sorry. That means that these are the same thing, so these will cancel. And then it's minus V naught squared. This is over 2A. So X final equals X initial plus V final squared minus V initial squared over 2A. And what we're just going to do is rearrange solve for, so we're just going to solve for V final. Because we already have an expression with X final, we want one for V final. So we're going to move over this guy first. So X final minus X initial equals V final squared plus V initial squared over 2A. We can condense this into delta X if we want, just to make it a little bit shorter. Multiply this over. And again, I don't expect that you can, you to have to derive these formulas. I'm just showing you where they come from in case you're curious. And it's also a good exercise in algebra to be able to do this. So V final squared equals V initial squared plus 2A delta X. And this is our final equation. So here's our 5 equations that you need to know to do kinematics well. I recommend you get familiar with them because you'll be seeing them quite a bit. Again, we won't really use this one too much, but it's there. One last thing I should mention, it's that these equations are only valid for constant acceleration. We're not going to be doing anything that's not constant acceleration, but just in case you are curious, like you go on in physics and you come back to this, and you're like, wait, these equations don't work for, something that's not constant, right? So if you ever come back to this, they're only valid for constant. You have new equations if they're not constant that you need to come up with for each situation. But yeah, work on memorizing this. You don't have to, but it helps. Helps to memorize. Oops. Helps to memorize. If not, get a note card, get a little 3x5 card, okay? So 3 by 5, right? Or is it 3 on this side and then 5 on this side? I actually don't know how they measure that. But, you know, get some index card and write down, write down all these equations, okay? And have them as a reference. Or just write these down somewhere where you can always look at them for problems, okay? So thank you for watching, and I'll see you in the next one.